Okay, in this question, first part, we have the function f of x equals 75 minus 6 into ln of x plus 1. And the question is this function increasing or decreasing on an interval that is given from 0 to 12? So first, before you even start doing anything, there is a logarithm in the question. So you need to make sure that whatever is within the logarithm needs to be more than 0, positive. Because logarithm, within it, it must have positive things. Okay, logarithm doesn't take 0 or negative as an input. So it's important to know this from the beginning. This means that what you have here, x plus 1, should be bigger than 0. This x plus 1 should be bigger than 0. So x must be from the beginning more than negative 1. So the domain of this function, it means all the x's that you can put in your formula. It's this, x bigger than negative 1. So the interval from negative 1 to infinity. This is the domain. All of this is not needed. I just wanted to remind you of it. But really, what you have to do, it's important that you understand the function before you start. But what you really have to do to know the behavior of increasing, decreasing, is to study the derivative, f prime of x. Because when it's positive, the function is increasing. So when f prime is bigger than 0, it's increasing. And when it's less than 0, it will be decreasing. So what we'll do is we'll do the derivative, f prime of x equals, so what is the function again? Look again. The function is 75 minus 6 times ln. So the derivative of 75 is 0 minus 6. And now the derivative of logarithm is just the derivative of what's within the logarithm, which is 1, over the thing within the logarithm, x plus 1. So again, I will just remind you, if you have ln of anything, diamond for example, and you are asked to do the derivative, then the derivative of this is the derivative of the inside of logarithm over the inside of the logarithm. You don't see a logarithm in the answer. You just see the derivative of the inside over the inside. The inside meaning is what's inside the logarithm in the formula. So here you see what's inside the logarithm is x plus 1. So you ask what is its derivative? Derivative is 1, and divide by it, x plus 1. So this is what we do with derivative of the entire thing, logarithm of this x plus 1. The derivative will be 1 over x plus 1. So that is why this will be negative 6 over x plus 1. And remember, because of logarithm, x plus 1 is always positive. This thing is always positive. And you are multiplying it by something that's always negative. So the entire thing must be always negative. Okay? So if you take any x in the domain, so in here, take any x, for example, x equals 0, or x equal 1, or x equal 2, doesn't matter. X can be anything, 3 and so on, and substitute them in this formula. So if you put 0, for example, in this formula, you'll have minus 6 over 0 plus 1, which is negative. If you put 1 in the formula, you'll get minus 6 over 1 plus 1, which is minus 6 over 2, which is minus 3, also negative. What I'm trying to tell you is that all of them will be negative for any x that you put, as long as x is in the domain. So this is a negative derivative all the time. And because it's always negative, it means that the function is always decreasing. So f of x is always decreasing. And of course, decreasing on all of R, and in particular on the interval 0 to 12. They're asking you specifically about the interval 0 to 12, but the thing is, this function is always decreasing. It's always coming down, you see? So there is nothing about it changing behavior. If it was changing from increasing to decreasing and then increasing back, for example, then you could study its behavior on a specific interval. But now you proved that it's always decreasing. And if you want to see the graph, let's see the graph of this. we go to Dismos and put it. It's 75 minus 6, 75 minus 6 ln x plus 1. And so let's look at what the graph looks like. So we put, we zoom out because it starts, at 0.75, because when you put x equals 0 in the formula, if you put x equals 0 here, you can notice this will be ln 1, ln 1 is 0, so the whole thing will be just 75. That's why you have the point here, 0.75. Yeah, it's nice to know these things. And look now, the function is always decreasing. Always decreasing, the graph. Look, if you take any point and keep on going with x, the y is coming down, always. Look at the y, it's always coming down. 72, then 71, and so on. Okay, you can even zoom out to see the decrease better, like this. And so you see the y is coming down, 60, 59, 58, now 54, and down, down, down. So how far down does it go? All the way down to the x-axis, and it goes below. Huh? So here it touches at this x and it continues below. Logarithm lives above and below the x-axis. Okay, so it's good that we saw this, and now we go back to the second part of this question. So this is always decreasing on any interval. So in particular, it will be decreasing on the interval that they're asking. Okay, so now let's go to the second part of this question. Find all inflection points, if any, of the following function. Remember, inflection points are points where the second derivative changes sign. So whenever you read inflection points, you know that you have to compute the second derivative. And to compute the second derivative, you know you have to first do the first derivative. So let's do it. This will be 15 x to the 4 minus 20 x cubed minus 0. The derivative of minus 1 is minus 0, but it's not important to put it. It doesn't do anything. And now the second derivative is 4 times 15 is 60x cubed minus 60x squared. This is the second derivative. And you can simplify it. Take 60x squared as a common factor, and inside you'll have x minus 1. Okay, this is f double prime of x. I prefer to look at it this way. Now, to get inflection points, you set this equal to 0 and check. If you set it equal to 0, then this means that either, if this here is 0, so here, if you set this here equal to 0, it will imply that x is 0 or x is 1. Because it will mean either this, if you want, you can say x squared is 0, or it means x minus 1 is 0. And then this will mean that x is 0, or this will mean x is 1. So x can be one of two possibilities. Are both of them inflection points? We don't know. We need to check. You can't guarantee that both are. So let's say the point 0 is here, and the point 1 is there. And here I will do f double prime. At 0 it's 0, and at 1 it's 0. And now take any number less than 0, negative 1 for example, and put it back in this formula. Put it in here, in f double prime. So if you have negative 1 and you put it in the formula, you'll get a negative answer. You try, it will be negative. Then this means that the function is concave down here. The behavior of f will be that it's concave down when the second derivative is negative. So here, you'll put that this means that f is concave down on this interval. Now choose something between 0 and 1, half, for example, and put half in this formula. You'll get also negative. You can try on your calculator. So still, it's concave down on this point. And finally, take something bigger than 1. Maybe you take 2 or 3 and put it in this formula. It will give you a positive answer. So this means that it's concave up on this interval from 1 to infinity. This will tell you that the change of concavity happens here, this one was concave down, and afterwards it became concave up. So this for sure here is an inflection point. We have an inflection point here at x equal 1. But on the other hand, at 0, even though the second derivative is 0 at 0, but it did not change the sign. The second derivative was negative, then negative. So the function kept on being concave down on both sides of 0. And this is why this is not an inflection point. Okay, and to see the graph, to just make sure that this is correct, let's draw the graph of this function now. So I will go to Dismos. In fact, we don't need Dismos now. We can do in the calculator. I'll do it. In our calculator, let's just graph this function. So I'll enter the function first. It's 3x to the 5 minus 5x to the 4, then minus 1. This is the function, so I say graph. And now let's just verify. This is what it looks like. It has if you say where are the inflection points, so it has just one inflection point at x equal 1. Notice the one at 0 is not an inflection point here when you go to the 0. It's concave down all the way before 0 and after 0. But at 1, when you go near x equal 1, before 1 it was concave down, and after 1 it's concave up. So the point at 1 is an inflection point. And of course, to get the y coordinate, you just replace it back in the point 1, negative 3. So if you put x equal 1, so put x equal 1 here, it will mean f of 1 equal 3 times 1 minus 5 times 1 minus 1. 3 minus 5 minus 2 minus 1 is minus 3. So this means that the inflection point is 1, negative 3. Okay, which is, let's see, was it the same as the point that we got in here? Yeah, 1, negative 3. See, it is the inflection point. Nice. And so I'll stop here.